Lesson: Access Control Strategies for Blockchain Systems. Access control strategies for blockchain systems are crucial for ensuring security, privacy, and compliance within decentralized environments. As blockchain technology continues to evolve, the implementation of robust access control mechanisms becomes increasingly vital. These mechanisms are designed to protect sensitive data, manage user privileges, and ensure that only authorized entities can interact with the system. In blockchain systems, access control strategies must address unique challenges such as decentralization, immutability, and transparency, while leveraging the inherent strengths of blockchain technology. Blockchain systems operate in a decentralized manner, eliminating the need for a central authority. This decentralization, while beneficial for transparency and security, poses challenges for access control. Traditional access control models, such as discretionary access control, mandatory access control, and role-based access control, are often inadequate for blockchain systems due to their reliance on centralized administration. Instead, blockchain systems must adopt decentralized access control models that align with their architectural principles. Decentralized access control models, such as attribute-based access control and policy-based access control, are particularly suited for blockchain systems. ABAC allows access decisions based on attributes of the user, resource, and environment, providing a flexible and dynamic approach to access control. PBAC, on the other hand, uses policies to govern access decisions, enabling fine-grained and context-aware access control. In blockchain systems, these models can be implemented through smart contracts, which are self-executing contracts with the terms of the agreement directly written into code. Smart contracts facilitate automated and transparent access control, ensuring that permissions and restrictions are enforced consistently across the network. One practical tool for implementing access control in blockchain systems is Hyperledger Fabric, a permissioned blockchain framework that supports fine-grained access control through its identity and membership services. Hyperledger Fabric allows organizations to define access policies based on roles, attributes, and other contextual information, enabling them to implement ABAC and PBAC models effectively. By leveraging Hyperledger Fabric, organizations can create customized access control mechanisms that align with their specific governance and compliance requirements. Another effective strategy for access control in blockchain systems is the use of decentralized identifiers and verifiable credentials. DIDs are unique identifiers that enable decentralized identity management, allowing users to control their own identities without relying on a central authority. VCs are digital statements that assert claims about an entity, such as a user's attributes or qualifications, and can be used to grant or deny access to blockchain resources. By integrating DIDs and VCs into blockchain systems, organizations can enhance their access control capabilities, ensuring that only authenticated and authorized users can access sensitive data or perform specific actions. A notable case study demonstrating the effectiveness of access control strategies in blockchain systems is the implementation of a decentralized healthcare data management platform. In this platform, patient data is stored on a blockchain, and access is controlled through a combination of ABAC and VCs. Patients can specify which healthcare providers can access their data and under what conditions, ensuring privacy and compliance with regulations such as the Health Insurance Portability and Accountability Act. By using blockchain technology to manage access control, the platform ensures that patient data is securely and transparently shared among authorized parties, improving the quality of care and reducing administrative burdens. In addition to healthcare, access control strategies are also essential in supply chain management, where blockchain systems are used to track and verify the provenance of goods. In a blockchain-based supply chain system, access control mechanisms must ensure that only authorized parties, such as manufacturers, distributors, and retailers, can access and update product information. By implementing ABAC and PBAC models through smart contracts, supply chain participants can establish trust and transparency, reducing the risk of fraud and counterfeiting. Furthermore, the use of DIDs and VCs can enhance identity verification and authentication processes, ensuring that only legitimate entities participate in the supply chain network. To address the challenges of implementing access control in blockchain systems, organizations can adopt a step-by-step approach that includes identifying access control requirements, selecting appropriate models and tools, and continuously monitoring and evaluating access control mechanisms. First, organizations must conduct a thorough analysis of their access control requirements, considering factors such as the types of data being protected, the roles and responsibilities of users, and the regulatory and compliance obligations they must meet. This analysis will help organizations identify the most suitable access control models and tools for their specific needs. Next, organizations should select access control models and tools that align with their identified requirements. For example, if an organization requires dynamic and context-aware access control, it may choose to implement ABAC or PBAC models through smart contracts. Similarly, if decentralized identity management is a priority, the organization may opt to integrate DIDs and VCs into its blockchain system. By selecting the right models and tools, organizations can ensure that their access control strategies are effective and aligned with their governance and compliance objectives. Once access control mechanisms are in place, organizations must continuously monitor and evaluate their effectiveness. This involves regularly reviewing access logs and audit trails to identify any unauthorized access attempts or anomalies, as well as updating access control policies and smart contracts to reflect changes in organizational requirements or regulatory obligations. By maintaining a proactive approach to access control, organizations can mitigate security risks, ensure compliance, and maintain trust among stakeholders. In conclusion, access control strategies for blockchain systems are essential for ensuring security, privacy, and compliance in decentralized environments. By leveraging decentralized access control models, such as ABAC and PBAC, and tools like Hyperledger Fabric, DIDs, and VCs, organizations can implement robust access control mechanisms that align with their governance and compliance objectives. Through practical applications in healthcare and supply chain management, these strategies have demonstrated their effectiveness in protecting sensitive data, managing user privileges, and ensuring that only authorized entities can interact with blockchain systems. By adopting a systematic approach to access control, organizations can enhance their proficiency in managing identity and access within blockchain systems, ultimately contributing to the success of their blockchain initiatives.